Welcome, everyone, to Vpod.ai. I'm your host, Mike, and I'm joined today by our expert, Susan.
Hi, Mike. I'm really excited to be here and get into this today.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit Vpod.ai to get started today.
That's an amazing deal, honestly.
Right. So whenever you hear people talk about fixing their blood sugar, or managing their metabolism, the conversation almost instantly goes to restriction.
Oh, absolutely. It's always about what you can't have.
Exactly. It is heavily focused on what you have to cut out. Stop eating this, eliminate carbohydrates entirely, restrict or restrict. But today, our mission is to completely flip that script.
Yeah, because we're looking at a really fascinating stack of clinical information that points to a radically different approach.
It really is. It turns out the fastest and most sustainable way to optimize your biochemistry is actually about adding specific foods, not just eliminating them.
Right. And it is a fundamental shift in how we approach diet and metabolism. We're moving away from the idea of just, starving the body of sugar to avoid a spike.
Which is what everyone tries to do.
Yeah, and instead, we're looking at how we can use food as biological instructions to actively repair the body's internal machinery. The goal is to get your body to a place where it can process glucose correctly again on its own.
And we are getting highly specific today. We're exploring 10 powerful foods that have been shown to reverse insulin resistance on a cellular level.
Naturally lowering blood sugar without just relying on medication.
Yeah. So to really understand how adding a food can lower blood sugar, we first need to look at how your body processes sugar at that microscopic cellular level.
And the research points us right into the pantry, actually.
Right, starting with two common spices that act directly on your cell's ability to absorb glucose. The first one is cinnamon.
Yeah, so to understand why cinnamon is so incredibly powerful, we have to look at the mechanics of insulin itself.
Okay, lay it out for us.
Well, when you eat, your body breaks down that food into glucose, which then enters your bloodstream. Insulin is the hormone released by your pancreas that acts like a shuttle.
Its entire job is to move that glucose out of the blood and into your cells, right?
Exactly, where it can be used for energy. But in a state of insulin resistance, which is what happens in prediabetes or type 2 diabetes, the cells essentially stop listening to insulin.
So it's like the insulin is knocking at the door, but the cell is just ignoring it.
Precisely. The insulin is circulating, the sugar is there, but the door will not open, so your blood sugar stays elevated.
And that sets off that whole destructive cascade of chronic inflammation and blood vessel damage.
Yeah, it really does. And this is where cinnamon steps in. Cinnamon contains an active compound called cinnamaldehyde.
Cinnamaldehyde.
Right, and cinnamaldehyde activates a very specific cellular pathway called IRS1-PI3K.
Okay, wait, let me pause right there because looking at the research notes here, IRS1-PI3K looks like a Wi-Fi password.
I know, the names are always a mouthful.
What is actually happening inside the cell when that pathway is activated?
So that pathway is essentially the internal messenger system of the cell. When insulin binds to the outside of the cell, it needs to send a signal down into the core.
To tell it what to do.
Exactly, to say, hey, bring the glucose transporters to the surface and let the sugar in. The IRS1-PI3K pathway is that messenger.
Okay, so in someone with insulin resistance, that messenger system is sluggish or broken.
Right. Cinnamaldehyde essentially repairs that communication line so the message gets through loud and clear.
I like to think of your insulin receptors as locks on a door, and insulin is the key. When you have prediabetes, those locks are rusty. The key just won't turn.
That's a really good way to visualize it.
So cinnamon, or specifically that cinnamaldehyde, acts like WD-40. It polishes and oils those cellular locks so the key fits perfectly again.
Yes. The message gets through and the door swings wide open to let the glucose out of the blood and into the muscle cells.
And while it's repairing that lock, cinnamon is also working in the digestive tract, right?
It is. It physically slows down gastric emptying. And on top of that, it inhibits an enzyme called alpha amylase.
Alpha amylase, what does that one do?
Think of it like a pair of chemical scissors in your gut that chops up complex carbohydrates into simple sugars. By blunting those scissors, cinnamon slows down the release of glucose into your bloodstream.
Wow, so you are slowing the influx of sugar while simultaneously helping shuttle more of it out of the bloodstream. That's a powerful combo.
It really is.
But for anyone running to their spice rack right now, the literature makes a massive distinction about the type of cinnamon we are talking about here.
Oh, this is crucial. You want to aim for about 1 to 2 grams daily, which is roughly half a teaspoon. but you need to verify you are using Ceylon cinnamon.
Not cassia cinnamon.
Right, not cassia. Cassia is the cheaper, much more common type you usually find in baking aisles, but it contains a compound called coumarin.
And coumarin is bad news at high doses, right?
Yeah, in the high daily doses we are talking about for metabolic repair, coumarin can actually be toxic to your liver.
Yikes. So definitely check your labels. Ceylon cinnamon has virtually no coumarin, making it much safer for daily use.
Exactly. Ceylon cinnamon all the way.
Okay, so Ceylon cinnamon for oiling the rusty locks. But looking at this structurally, I do have a question.
Sure, go ahead.
If we're using compounds to make the body respond better to insulin or release more of it, doesn't that carry a risk? Like if I'm fixing the locks and flooding the system, don't I risk dropping my blood sugar way too low, like into hypoglycemia?
That is actually the primary concern with a lot of conventional synthetic diabetes medications. They force the pancreas to pump out insulin regardless of what your blood sugar is doing.
Which leads to those dangerous crashes.
Exactly. And this brings us perfectly to our second pantry staple, fenugreek seeds, which offer a biological workaround to that exact problem.
Fenugreek seeds, I've seen those in a lot of spice blends.
Yeah, they're common in Indian cuisine.
Yeah.
Fenugreek contains a very rare amino acid called 4-hydroxyisoleucine. This compound actively stimulates the beta cells in your pancreas to release more insulin. However, the brilliance of this amino acid is that it only triggers that insulin release when your blood sugar is elevated.
Oh, I see. So it's not just a blind switch permanently flipped to on.
Right. It acts as a targeted glucose-dependent sensor. It makes your pancreas highly responsive to excess glucose after a meal. But the moment your blood sugar levels normalize, the stimulation stops.
So you get the benefit of cleared blood sugar without the risk of a hypoglycemic crash. That's incredible.
It is. And additionally, fenugreek contains galactomannan. This is a type of soluble fiber that, when it hits your digestive tract, forms a really thick gel.
I'm guessing that gel slows things down.
Yeah, that gel coats your stomach lining and physically slows down the rate at which sugars can be absorbed into the blood.
The clinical outcomes listed in the research are really impressive. Lowering fasting blood sugar, reducing A1C, dropping LDL cholesterol. There's even data suggesting it can boost testosterone in men.
Yeah, it's a multitasker for sure.
Yeah. But practically speaking, how is someone supposed to consume fenugreek? I mean, I can't imagine chewing a spoonful of dry, bitter seeds.
No, definitely don't do that. The most effective method is to take about 1 teaspoon of the seeds and soak them in a glass of water overnight.
Okay, so it softens them up.
Right, and by morning, the water has extracted a lot of those active compounds. You drink the water and chew the softened seeds first thing.
Are there any side effects to look out for?
Yes, there are some serious cautions to observe. You must start with a very low dose because the gastrointestinal side effects can be pretty intense as your gut microbiome adapts.
Oh, good to know. Start slow.
And furthermore, you absolutely want to avoid fenugreek during pregnancy because of its effects on uterine contractions. And we lack safety data on whether these active compounds pass through breast milk, so avoid it while breastfeeding too.
Makes sense. Better safe than sorry.
Finally, fenugreek is a legume, and there is known cross-reactivity. If you have severe allergies to peanuts or soybeans, you need to exercise extreme caution or just avoid it entirely.
Got it. Okay, so step 1 is fixing the cellular locks and the pancreas sensors with cinnamon and fenugreek. But the metabolism is an interconnected web.
It really is, yeah.
What happens if the issue isn't just the cells refusing to take sugar in, but the liver actively pumping out way too much sugar on its own? Because the liver acts as the body's emergency sugar reservoir, right?
Exactly. And the next category of foods acts remarkably like pharmaceutical drugs to reach in and turn off that internal sugar faucet.
Okay, let's get into it. We're looking at broccoli sprouts next.
Right, so broccoli sprouts are essentially botanical metabolic reprogrammers. And we are not talking about mature, full-grown broccoli crowns here.
We are talking about the 3 to 5 day old baby plants.
Yes. At that early stage of life, they contain 20 to 100 times more of a compound precursor for something called sulforaphane compared to mature broccoli.
Wait, 20 to 100 times more. Why is the baby plant hoarding so much of this specific compound?
It's a defense mechanism, actually. The baby plant is incredibly vulnerable, so it packs itself with these sulfur-based compounds to deter insects.
Okay, that makes sense from an evolutionary standpoint.
But when humans consume sulforaphane, it acts as a mild positive stressor that activates a transcription factor in our bodies called NRF2.
NRF2,
Think of NRF2 as your body's master internal thermostat for inflammation and oxidative stress. When sulforaphane flips that NRF2 switch on, it triggers a cascade of protective genes.
And how does that tie back to blood sugar?
Crucially, it tells your liver to stop producing new sugar. The medical term for this is inhibiting gluconeogenesis.
Gluconeogenesis, literally the creation of new glucose.
Right, because in insulin resistance, the liver often gets confused and thinks the body is starving, even
Right.
when blood sugar is high, so it continuously dumps more glucose into the blood.
And sulforaphane halts that process.
Exactly. What is truly remarkable is that this is the exact same cellular mechanism of action as metformin, one of the most widely prescribed diabetes medications on the planet.
Oh, wow, that's a huge comparison.
It intercepts the liver's chemical signals and says, there is enough sugar in the blood already, stop making more. And to achieve this, you only need about half a cup of raw sprouts daily.
Let me push back here, though. Looking at the chemical breakdown in the clinical data we have, it highlights that sulforaphane is a notoriously unstable compound.
It is very unstable.
It has a very short half-life in the human body. Does that mean eating a massive bowl of broccoli sprouts on a Sunday won't provide any metabolic coverage by Wednesday?
Yeah, that is the catch. You cannot bank sulforaphane for later. Because it is highly reactive and clears out of your system quickly, you need a steady daily supply to keep that NRF2 pathway activated.
So half a cup raw every single day, or at least most days.
Yes, and they must be raw. Cooking them destroys the enzyme myrosinase, which you need to convert the precursor into active sulforaphane. Consistency is the only way to keep that liver-suppressing switch engaged.
I mean, you wouldn't take a week's worth of a prescription on a Sunday and expect it to regulate your body all winter. The food acts the exact same way. So we have broccoli sprouts acting like metformin. But the biology gets even more specific when we look at grass-fed beef and avocados, because they target something called the PPAR gamma receptor. What exactly is that receptor doing?
So the PPAR gamma receptor is a major regulator located inside your fat cells. Its job is to control how sensitive those cells are to insulin and how they store fatty acids.
Okay, so it's a traffic cop for fat.
Basically, yeah.
Okay.
When PPAR gamma is activated, it tells your fat cells to safely tuck away circulating fats. This prevents those fats from getting lodged in your liver or muscle tissue where they cause severe insulin resistance.
And the research shows there's an entire class of synthetic diabetes medications, like pioglitazone, designed specifically to target and artificially activate this exact receptor.
But the research indicates we can activate it nutritionally as well.
Which is where the grass-fed beef comes in.
Right. Grass-fed beef, and it specifically must be grass-fed, has significantly higher concentrations of omega-3 fatty acids, alpha-linolenic acid, and importantly, conjugated linoleic acid, or CLA.
CLA.
Yeah.
I've seen that in supplements.
Yeah, CLA is a naturally occurring fatty acid that directly binds to and activates that PPAR gamma receptor to enhance overall glucose uptake and insulin sensitivity.
There is also a mention here of L-carnitine in the beef. The literature describes it almost like a cellular shuttle service.
L-carnitine is crucial. Think of your cells' mitochondria as tiny furnaces that burn energy. Fatty acids cannot just wander into the furnace on their own. They need to be carried in.
So L-carnitine is the molecule that physically shuttles those fatty acids through the mitochondrial wall so they can be burned for fuel.
Exactly. Without enough L-carnitine, those fats accumulate in the liver, leading to a fatty liver, which is a primary driver of high blood sugar.
The obvious caveat here, of course, is that this isn't a license to eat a highly processed fast food burger every day and claim it's fixing your metabolism.
Oh, far from it. We are discussing unprocessed, high-quality grass-fed beef. And the nutritional data strongly emphasizes pairing it with high-fiber foods to maintain a healthy gut microbiome. It is a tool, not a free pass.
But if you were looking for a plant-based way to hit that same PPAR gamma receptor, avocados are the answer.
Oh, definitely. Avocados are extraordinarily rich in oleic acid, a monounsaturated fat that helps the body oxidize or burn fat and clear out liver fat.
And they also provide a massive dose of potassium, right?
Yes, which your cell membranes require to maintain the electrical gradients that allow insulin receptors to function.
The satiety is a huge factor with avocados, too. The data notes that adding just half an avocado to a meal improves feelings of fullness for 3 to 5 hours.
And if you are full, you aren't grazing on snacks.
Exactly, which means you aren't spiking your blood sugar every 2 hours, giving your pancreas a much-needed rest.
It breaks that cycle of continuous insulin demand.
Let's map out where we are so far. We have used spices to oil the cellular locks so glucose can enter. We've used sprouts and healthy fats to tell the liver to stop overproducing sugar and clear out the fat blocking the system. But to keep blood sugar low sustainably over the long haul, we need to build up the body's physical infrastructure so it can dispose of glucose effortlessly on a daily basis.
And that requires building lean muscle and lowering the chronic background inflammation that scrambles cellular communication.
Let's look at eggs and fatty fish for that.
Okay, so eggs are an absolute powerhouse for metabolic recovery. They contain high levels of choline, a nutrient that acts as a fat mover in the liver.
What does that mean, fat mover?
Choline packages up the fat sitting in the liver and exports it out into the bloodstream where it can be used, directly resolving the fatty liver conditions that cause insulin resistance.
Wow.
Furthermore, eggs are rich in leucine, an essential amino acid that serves as the primary trigger for muscle protein synthesis.
Let me synthesize this with an analogy, because the connection between muscle mass and blood sugar is such a vital concept.
Go for it.
If your liver and your cells are the engine of your car, your muscle mass is the fuel tank. Every time you eat carbohydrates, that glucose needs a place to go. The bigger your fuel tank, which you build using the leucine from eggs combined with resistance training, the more excess glucose you can safely pull out of your bloodstream and store away as glycogen.
That's perfect. Your muscles are your body's largest glucose sink. A larger, more active muscle mass acts like a vacuum for blood sugar.
But while you are building that tank, you simultaneously need to extinguish the fires of chronic inflammation. This is where fatty fish comes in.
Yes, salmon, mackerel, and sardines are loaded with EPA and DHA, which are highly bioavailable omega-3 fatty acids.
I mean, most people know omega-3s are quote-unquote good, but how are they actually fixing blood sugar?
They do it by altering the cell membrane itself. EPA and DHA integrate themselves into the physical walls of your cells.
Okay, so they become part of the structure.
Right. When your cell walls are made of these flexible anti-inflammatory fats rather than rigid inflammatory omega-6 fats, the insulin receptor sitting on that wall can move and function much more efficiently.
And we see this validated in clinical trials, right? One notable study showed that consuming 750 grams of fatty fish per week for 8 weeks significantly improved how the participants' bodies regulated glucose in the hours immediately following a meal.
Yeah, that's a really significant finding.
750 grams a week is a solid commitment to salmon. But the mechanism makes total sense. You are rebuilding the cell walls to be more receptive.
Exactly.
Moving along the anti-inflammatory spectrum, the literature brings us to walnuts and chia seeds. These two do something highly specific to our hormones and digestion.
Let's start with walnuts. They're unique because they actively influence the fat cells to secrete a hormone called adiponectin.
Adiponectin, what does that do?
It's a fascinating molecule. It travels from your fat tissue to your muscles and your liver, essentially telling them to increase their sensitivity to insulin and to start burning fatty acids for energy rather than storing them.
So higher levels of circulating adiponectin are strongly correlated with a lower risk of type 2 diabetes.
Exactly. Walnuts also provide a dense source of magnesium, an elemental mineral that the insulin receptors physically require to activate the internal cellular pathways we discussed earlier.
And then we have chia seeds, which physically alter the digestive environment. When you take chia seeds and soak them in water, they expand and form this thick, viscous gel.
Yes, they do.
If you picture your intestinal tract as a highway where carbohydrates travel to get absorbed into the blood, that chia gel acts like a massive speed bump.
That's a great image.
It physically surrounds the carbohydrates in your gut, slowing down the digestive enzymes trying to break them apart.
It literally changes the geometry of your digestion. Instead of a rapid breakdown that results in a massive spike in blood sugar, the carbohydrates are trapped in this gel matrix.
So they are broken down slowly.
Right, resulting in a steady, gradual release of glucose into the blood that your pancreas can easily handle without panicking.
The research also notes that the plant-based alpha-linolenic acid in those chia seeds actively decreases CRP. For those listening, CRP stands for C-reactive protein, which is essentially an alarm bell your liver rings when there is systemic inflammation anywhere in the body. Lowering CRP means the alarm is turned off.
And the cells can stop playing defense and return to normal metabolism. Which brings us to the final and perhaps most complex piece of the metabolic puzzle.
The gut microbiome.
Right. The digestive tract isn't just a tube where we absorb nutrients, it is an ecosystem. Optimizing blood sugar isn't just about what our human cells are digesting.
It's heavily dependent on what the trillions of bacteria in our gut microbiome are digesting. We need to examine chickpeas.
Yes, chickpeas.
So the primary ingredient in hummus. How are chickpeas fundamentally changing our cellular biochemistry?
It comes down to the architecture of the carbohydrates within the chickpea. Most of the starches people consume daily, like those in white bread, potatoes, or regular pasta, are rapidly digestible starches.
They hit your stomach, turn to simple sugar almost instantly, and flood your bloodstream.
Exactly. Chickpeas, however, are predominantly composed of amylose. Amylose is a tightly packed, resistant starch.
Meaning it resists immediate digestion.
Yes, which naturally blunts any initial blood sugar spike. But the real metabolic magic happens further down in the large intestine.
Because that resistant starch makes it all the way down intact.
Yes. Chickpeas contain specific fermentable fibers that human enzymes cannot break down, but the bacteria in your gut microbiome can.
And they ferment this fiber.
Right. And as a byproduct, they secrete short-chain fatty acids. The most critical one for metabolism is called butyrate.
I am seeing butyrate mentioned constantly in emerging metabolic literature. Why is this specific fatty acid so vital?
Butyrate acts as a signaling molecule that exerts systemic effects across the entire body. Locally, it provides the main energy source for the cells lining your colon.
Strengthening the physical gut barrier so inflammatory compounds cannot leak into your bloodstream.
Exactly. But systemically, butyrate improves the function of an enzyme called AMPK.
Okay, let's define AMPK for the listener, because it sounds like another piece of cellular alphabet soup.
Fair enough. AMPK is essentially your cell's low battery indicator. It is a master energy sensor.
Okay?
When AMPK gets activated, in this case, triggered by the butyrate produced by your gut bacteria, it alerts the cell that it needs to generate energy.
So the cell responds by pulling glucose out of the bloodstream and into the mitochondria to be burned.
Exactly. It literally forces your metabolism into a more active, efficient state.
So to trace that incredible chain reaction, by eating chickpeas, we are feeding specific bacterial colonies in our gut so they can ferment a fiber, so they can produce a chemical called butyrate, so that butyrate can travel through the body to turn on an enzyme called AMPK, so that enzyme can force the cells to clear excess sugar from our blood.
It's amazing when you lay it all out like that.
The microscopic chain of custody there is just staggering.
It highlights how deeply interconnected our diet is with our biology. But as with the broccoli sprouts, this isn't about eating hummus once a month at a party.
Right. To achieve a therapeutic medicinal effect, you have to actively cultivate and sustain that specific population of gut bacteria.
And that requires routine. The data suggests incorporating at least 1 cup of chickpeas a few times a week, whether in salads, roasted, in soups, or as hummus.
You have to consistently provide your microbiome with the raw materials it needs to produce that butyrate daily.
Exactly.
Well, let's bring all of this together. The paradigm we started with, that fixing your metabolism requires a miserable, soul-crushing exercise in restricting everything you love, is completely obsolete based on this clinical data.
Completely.
Optimizing your blood sugar is about treating food as a set of biological instructions. You're adding Ceylon cinnamon to act like WD-40 on your sluggish cellular locks. You're consuming broccoli sprouts to hit the exact same genetic switches as metformin, shutting down the liver's overproduction of sugar.
Right, and you're building up a muscular fuel tank with the leucine in eggs and literally farming a microscopic ecosystem in your gut with chickpeas so those bacteria can repair your cellular enzymes from the inside out.
You are engineering your metabolism from the ground up, just by adding the right chemical messages.
It places the power entirely in the individual's hands. It moves you away from a passive state of just hoping to avoid a blood sugar spike into an active state of utilizing nutrition to fundamentally repair the machinery.
You are providing the exact molecular tools your body needs to correct the dysfunction.
It really is a totally empowering framework.
Which leaves us with a final thought to chew on as we wrap up this exploration. If a handful of baby broccoli sprouts or a spoonful of soaked chia seeds can fundamentally alter how our genes express themselves, repair cellular communication pathways, and act almost exactly like highly engineered prescription medications, what other microscopic chemical conversations are happening inside your body with every single bite you take?
It really guarantees you will never look at your dinner plate the same way again.
It absolutely does. Thanks for joining us for this discussion. We'll catch you on the next one.